Hi everyone, I am Rajalakshmi working as an assistant professor in the Department of ECE at R.M.K College of Engineering and Technology. I am going to deal with the subject EC8791 Embedded and Real-Time Systems. So this video is all about the introduction to ARM processor. So the image, what I have shown here are the few leading manufacturers of ARM processors. The first one is NXP, which is the earlier, which is called as Philips. Analog Devices, Maxim Integrated, STM32 Cortex, Cypress, Microchip, Stira from Texas Instruments. So these are few leading manufacturers of ARM processor. Actually, the ARM does not manufacture processors or rather semiconductor devices, but they licenses the semiconductor cores as intellectual property to other semiconductor companies like Atmel, Philips and Samsung. So now what is ARM? So the ARM stands for Advanced RISC Machine, so which is a 32-bit reduced instruction set computer microcontroller. So this ARM processor was first introduced by the Acorn Computers organization in the year 1987. So ARM is the world's leading producer of RISC-based microprocessor solutions and other semiconductor IPs with more than 85 billion ARM-based chips being shipped to date. So ARM is one of the most licensed and thus widespread processor cores in the world. So ARM is being used in personal digital assistants, cell phones, multimedia players, handheld games, console, digital TVs and cameras. So all are because of their less power consumption. So we have versions of ARM architectures. So ARM 7 it is being used in Game Boy assistants, iPods, ARM 9 which finds its applications in NDS, PSP, Sony Ericsson and band. So the next version, ARM11, finds its application in Apple iPhone, Nokia N93, N88. So most of the 32-bit embedded RISC processor till 2019 is ARM processor. So ARM is used because especially in portable devices due to its low power consumption and reasonable performance. So before entering into the architecture of ARM processor, you should know what are the basic computer architecture taxonomy. So in basic computer architecture, we have four different types. The first one is von Neumann architecture. The second one is hardware architecture. The third one we have is CISC, which stands for complex instruction set computers. The next one we have is reduced instruction set computers, which is RISC. So now you can see the architecture of a von Neumann architecture. So we have the central processing unit within which we have is your PC, which stands for program counter, which always points to the instruction which is to be executed, which is that is your program counter points to the address of the instruction that is to be executed. So coming to the memory, we have a single memory which is being shared for storing your data as well as your program. There is no separate memory for storing your data as well as your program. That is what your von Neumann architecture. I'll repeat once again. So you can see the image of von Neumann architecture. You have the central processing unit within which you have your program counter. You have a single memory which is being shared for storing your data as well as your program. Now coming to the hardware architecture, you can see here you have a central processing unit within which you have is your program counter. So as I already told, the program counter points to the address of the instruction that is to be executed. So coming to the memory, you have two different memory, that is one dedicated for storing your data and the next part of memory which is dedicated for storing your program. So this is what the hardware architecture. So each architecture has their own advantage. So now getting into the next architecture, which is your CISC, which stands for Complex Instruction Set Computer. So it is known as Complex Instruction Set Computer. It was first developed by Intel. So it contains large number of complex instructions. So in this, the instructions are not register based, which is the instructions are always memory based. Instruction cannot be completed in one mission cycle, which means it needs more than one mission cycle to complete the execution of one instruction. Data transfer is from memory to memory. Microprogrammed control unit is found in CISC. Also, they have variable instruction format. That is, they don't follow a fixed instruction formats. Coming to the last architecture, which is reduced instruction set computer, RISC, is a type of microprocessor architecture that uses highly optimized set of instructions. That is, the length of the instruction will be very less. That is what it is, reduced instruction set computers. A reduced instruction set computer is a computer with a small, highly optimized set of instructions rather than more specialized set of often found in other types of architecture. So RISC architecture is used in portable devices due to its low power consumption. So the real-time example where we found our RISC architecture is Apple iPod and Nintendo DS. So now let me give you the difference between von Neumann architecture and Harvard architecture. You can see the image. So von Neumann architecture, you have a single memory which is shared for storing your data as well as your program. Whereas coming to the Harvard architecture, you have a separate memory which is dedicated for storing your data, and you have a separate memory which is dedicated for storing your program. So this is what the difference between the von Neumann architecture as well as your Harvard architecture. So in ARM processor, we have several versions of ARM processor. So the ARM7 processor uses von Neumann architecture. The remaining versions of ARM processor, ARM 9, 10, 11, they follow Harvard architecture. So now let me give you the difference between your CISC and RISC architecture. So CISC architecture, the instruction can take several clock cycles, whereas in RISC, single instruction can be executed within a single clock cycle. So coming to CISC, complex and variable length of instruction. In RISC, all the instructions will be of same length. So CISC is based on memory to memory operation, whereas RISC is based on register operations. Coming to CISC, small code sizes, higher cycles per second. So RISC, low cycles per second, large code sizes. So this is the difference between your CISC and RISC processors. Now coming into the features of our ARM processor. So the ARM processor is RISC based architecture. It follows load and store architecture where all the operations is based on registers. That is, whenever your ARM processor wants to perform some processing, it always fetches data from the memory. Data will be placed in the registers. Operations will be performed in the registers. Once the operation is completed, the data, that is the result, will be stored back into the memory by using the instruction which is called as store. So that is what we call it as load and store architecture. That is, first it will load the data from the memory into the register, performs the operation. Once the operation is completed, the result will be stored into the memory. And next one, ARM follows thumb instruction, which is, we know that ARM is a 32-bit processor. So even though it is a 32-bit processor, it can able to deal with 16-bit instruction sets. That is what we call it as thumb instruction set. So ARM processor follows multiple stage of pipelines. So you know pipeline is parallel execution of instruction. So ARM processor allows multiple stage of pipelines. So apart from this, the ARM processor has good megahertz frequency ratio and it allows wide frequency range. ARM processor allows direct Java execution. It has inbuilt debugger. It provides options for instructions for digital signal processing. Now getting into the three architecture profiles of ARM, we have A profile, R profile and M profile. So the A profile, it stands for application, R profile, it stands for real time, M profile, it stands for microcontroller. So from the name itself, you can able to understand the A profile, it will be used directly in the application areas. So the A profile have high performance and it is specifically designed to run a complex operating systems such as Linux or Windows. Coming to the R profile, which is named as real time, it will be used in real time applications. So it is targeted at system with real time requirements. So any system whose output is expected to be produced within a specified time, that kind of system we call it as real time systems. So this R profile is targeted for that type of real time requirements. So it is commonly found in networking equipment and embedded control systems. Coming to the M profile, so which is named as microcontroller. So it finds applications in small and it is highly power efficient devices. So it is found at the heart of many IoT devices. So that's all about the introduction of ARM processors. Thank you.